Hi and welcome to E-ZTutoring. Today we're going to cover how to factor using synthetic division. So this video we're going to cover a number of things. We're going to cover synthetic division, possible zeros using P over Q, and then setting it up in a factored form. Alright, so let's suppose we have the function 2x cubed minus 5x squared minus 28x plus 15. Oh, one more thing we're going to cover is remainder theorem. I already did a video on remainder theorem, so if you haven't seen that, be sure to check it out. Now we're going to use remainder theorem to find out which one of our possible zeros is going to work. So let's go ahead and first find our possible zeros. This is P, and this is Q. Your last and your first numbers. To find your possible zeros, all you do is you set up plus or minus P over plus or minus Q. And you are going to get a lot of numbers. For your P, you want to set up all of your possible factors of P. So what are all the possible factors of 15? We've got plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Over Q. What are the possible factors of Q? Plus or minus 1 and plus or minus 2. So, in order to find all of your zeros, what you would do is you would do 1 over 1, 1 over negative 1, 1 over 2, 1 over negative 2, 3 over 1, 3 over negative 1. You guys get the point. There is a lot. So, what I'm going to do is I'm going to start off with some very simple zeros. So we know that some of our zeros we're going to have, actually let me go ahead and just write some of them out. This will make life a little bit easier. We'll have negative 1/2 and 1/2. We'll have 1 and negative 1. We'll have 3 and negative 3, 3 halves and negative 3 halves, and so on. Now, we're not going to use the fractions. Of course, we want to try out the easy numbers first because that will make life easier. So, using the remainder theorem, we know that if we plug these numbers in and we get 0, therefore that number will synthetically divide. So let's try 1. We get 2 times 1, 2, minus 5, negative 3, minus 28, negative 31, plus 15. Definitely not 0. We want a remainder of 0. All right, so let's try negative 1. We get negative 2, minus 5, negative 7, plus 28, 21, plus 15, not equal to 0. Let's try 3. So this one I might actually have to write out here. If we plug in a 3, over here we will get 27 times 2, 54. Minus 9 times 5, 45. So far this will give us 9. Minus 28 times 3. So that gives us 84? 26? Yeah, 84. Well, negative 84. So minus 84 plus 15. So 9 minus 84 plus 15. Definitely not a 0. We could try negative 3 now. So if we try negative 3, we'll get the same numbers, but really all that's going to happen is this one will turn negative and this one will turn positive. So now let's see if that gives us 0. That looks like it might give us 0 because negative 54 minus 45 is negative 99, and these are plus 99, which equals 0. So we just used the remainder theorem and found out that negative 3 is indeed a 0. So would you rather have spent all that time synthetically dividing 3 different numbers or just using the remainder theorem? All right, well, anyways, it took a little longer than expected, but we can actually go ahead and start using synthetic division now. So we set it up using all the coefficients in front of the x's, and of course you do have to include the signs. So we would get 2, negative 5, negative 28, and 15, and we are going to synthetically divide by negative 3, because we know that that is a 0 of this polynomial. So what we do is we bring down the 2. You will always bring down your first number. Then what you do is you multiply this number by whatever you're synthetically dividing by, -3. 2 times -3 is -6. Then we put a -6 here. Then you just add these. -5 plus -6 gives us -11. And you repeat the cycle. -11 times -3 is +33. Add these, that gives you 5. 5 times -3 is -15. Add these, that gives you 0. Your last number is always your remainder. If you got a remainder of 0, you are a lucky man. So now we can actually kind of start over here. We don't want to look at these possible zeros anymore. Now we will have a new set of possible zeros because now we have a new polynomial, or I should say trinomial. So what we want to do is we want to add the x's back onto these numbers. So we will get 2. It's no longer x cubed because we divided by an x. So now it's going to be x squared minus 11x plus 5. And the -3 as a 0, all you do is you change the sign and put it as a binomial. So it's x plus 3 times that. So far we've got one factor of x plus 3. And like I said, can't stress this enough, you must change the sign when putting it in binomial form. All right, so now we want to find the possible zeros of this. So once again, we do plus or minus p over plus or minus q. P is 5, so factors of 5 are easy, 1 or 5. That's it. Q is just 2, so plus or minus 1, plus or minus 2. So now we get a lot less possible zeros. We get 1/2, -1/2, 5 halves, -5 halves. And you obviously want to test these zeros instead of the old zeros, because if you tested the old zeros, you remember there were a lot, which maybe would have been here pretty much all day. So now we got a much shorter list of zeros. And of course, you do want to start off with your whole numbers because we don't like fractions here. Anyways, if we plug in a 1, we get 2 minus 11, -9, plus 5, not 0. What about -1? 2 plus 11 plus 5, no. What about 5? 2 times 25 is 50, minus 55 is -55, plus 5 is 0. 5 works. 5 is our 0. So using the remainder theorem, we only have to synthetically divide one time. We don't have to try out all the zeros. All right, so 5 is going to be our divisor. And now we are dividing into this new trinomial. 2, -11, 5. We don't want to include the x's when you do this. All right, so you guys are familiar with synthetic division now. We bring down the 2, multiply by the 5, get 10, add these, get -1, multiply by the 5, get -5, and look at that, we get a remainder of 0, which is exactly what we want. So now if we put the x's back on, we will have x plus 3, which was our first divisor. And now we must change the sign of this. So instead of 5, we must put x minus 5. If you guys are wondering how this works, is because plugging in 5 for x is what makes this 0. So your 0 is 5, not -5, which is why you change the sign. Anyways, now we put x's back here and we get 2x minus 1. This is as factored as you can get. So just like that, we went from this form all the way over here to a fully factored form. So work smarter, not harder, guys. Whenever you want to factor, be sure to use the remainder theorem to make life a little bit easier. If you still are not familiar with the remainder theorem, be sure to check out my video on it. So, hope this is a lot easier for you now than it was before. If you guys need help with ACT or SAT, be sure to visit my website, www.e-ztutoring.com. Thank you guys and have a good day.